It's an interesting word problem. I got to think about it a second. I don't think it's that hard, but let me think for a moment here. X plus Y plus Z is 27. And X has 1/5 of A plus 2/5 of B plus 2/5 of C.
So where did you come up with the fifths from?
Well, if I take this, if I had 5 gallons of X, 1/5 of that, or 1 gallon, would be chemical A, 2 gallons would be chemical B, and 2 gallons would be C.
Okay.
Okay. So following that same logic, that takes care of X.
Y would just be A.
Y would be just C. All of it is C. However many gallons of pet spray number Y is going to be all C.
Okay.
Plus Z would be 1/3 A plus 1/3 B plus 1/3 C.
Okay.
Now, if I add those all together to get 27, I've got one equation and 3 variables. I can come up with another equation that says A plus B plus C is 27. Hold on here. Let's see. For every gallon of X, I'm going to have 1/5 of A in other words, this is per gallon of X. Gives you every gallon of X. I'm not thinking about this correctly. Let me see if I can think of another way to do this. Let's see. X plus Y plus Z has to equal 27 gallons.
Yeah.
And 1/5, aha! Let's go back. Six gallons has to equal that part of X, that part of Z, right?
Yes.
In other words, 1/5 X plus 1/3 Z has to equal 6. That's the way we're going to do this problem.
That makes much more sense.
Now, for Y,
8 would equal 2.
Y is all C. So 13 has to equal 2/5 X plus all of Y plus 1/3 Z. And the third equation is 8 gallons equals 2/5 x plus 1/3 z.
Okay.
There's
So can we base?
your 3 equations and 3 unknowns. Now you have a system of linear equations, and as long as you have as many equations as unknowns, then you can solve it. Okay?
Okay.
Notice that I don't have to work with a 3 by 3 here. If I take this equation 1 and this equation 2, I have 2 equations and only 2 unknowns. And I can actually solve that rather quickly for x and z. Once I solve for x and z, then I go into this middle equation, substitute x and z, and I can solve for y.
Okay. All right.
Okay, so let's do that. Let's lay these 2 equations out. I'll lay them out in standard format. 1/5 x plus 1/3 z has to equal 6, and 2/5 x plus 1/3 z has to equal 8. Well, notice I can subtract, if I call that 2 and this 1, I can subtract 2 minus 1 to eliminate z.
Right.
And leave myself with all positive coefficients.
Yeah. Mm-hmm.
I've eliminated z, and now I've solved for x. X equals 10. So there's 10 gallons of x needed.
Then you can plug that in one of your other equations.
You can plug it into either equation to solve for z. Let's plug it into the one with the lowest numbers. So I've got 6 equals 1/5 times 10 plus 1/3 z. Well, that's 2. Take that 2 over the other side. I got 4 equals 1/3 z. Z equals 12.
And then plug that back into the big equation.
Yeah, plug that into the equation. Or actually, I don't even need to at this point. I know they have to total 27 gallons. I got 22. That's got to be 5.
Right. Okay.
I actually had 4 equations and 3 unknowns. But I don't even need this equation here. I can go into this one. Yeah. The third equation we haven't worked with yet, and plug in an x of 10 and a y of 12, and figure out that z is 5. And let's just see if that works.
Right.
An x of 10, a y of 12.
Isn't it a z of 12?
Yeah. Sorry.
Okay. Yeah.
And the z of 12, we'll just leave that y for the moment. Well, let's see, that's 4. Third of 12 is 4. I subtract both those 4's from the other side, I get y equal 5. Or rather, yeah, I got these backwards, didn't I? Yeah, this is, y is 5 and z was 12.
Okay. All right.
That is a good problem. That is a little tricky on how to set up.
Yeah, I never would have figured it out. Yeah.
And there's probably multiple ways to do it. I'm not sure I did it in the most efficient way, but I'm sure I did it correctly. Yeah. I think I probably did do it in the most efficient way. But, yeah, that's a tough problem. What algebra are you taking? Algebra 2 honor?
I'm in pre-calc. No, I'm in pre-calc.
Pre-calc. Oh, no wonder. Okay. That makes a little more sense.
Yeah.
For some reason, I had remembered you were Algebra 2. But, yeah, in pre-calc, you're going to even be asked to solve systems of 3 equations and 3 unknowns. which
that was one of my.
Can be a little tricky. That one was not tricky.
Yeah.
The trickiest part about that one was setting up the three equations. The reason it was easy to solve is because we actually had two variables in two of the equations, and one of the equations didn't. I mean, we could take these first two equations and solve for x and z. Usually you can't do that. If you end up normally where you have three equations and each one has three variables, then it's a much more complicated process to solve for all three variables. You kind of have to eliminate one variable twice and end up with two equations and two unknowns, solve that, and then work backwards from there. If you have a problem like that, I'm happy to go through it with you. This kind of was that, but they set this one up such that you really didn't have three variables in each equation.
Yeah, I mean, for me, finding what the equations are is always the most challenging part.
That one was particularly tricky, for sure.
Yeah. All right, so I have one last problem that was really stumping me, and yes, it is another word problem.
It's okay.
Okay, so it goes, a student is working part-time as a cosmetologist to pay college expenses. The student may work no more than 24 hours per week. Haircuts cost $17 and require an average of 20 minutes. Permanents cost $60 and require an average of an hour and 10 minutes. What combination of haircuts and/or perms will yield a maximum revenue? What is the maximum revenue?
Okay. Well, the biggest problem with word problems, or the thing you want to start out, is always define your variables. Okay?
Right.
So let's pick some variables. Let's let x equal the number of haircuts.
Okay.
Let's let y equal the number of permanents. And I think it's important when you're doing these word problems to spell it completely out. Because if I just say x equals HC, does that mean the price? The time? So I'm going to let x equal the number of haircuts you give.
Right.
Okay? So what is the total income that you're going to get, which is the objective function that you want to maximize, right? In other words, this is a linear programming problem. So I don't know if you call it objective function or not, do you?
That's like the x plus y is less than 24, right?
No, that's a condition. And it's not quite x plus y. Let's first of all talk about your income. The income equation is the number of haircuts you give times 17 plus the number of permanents you give times 60.
Okay.
Correct?
Yes.
So that's your income. 17x
and
plus
then,
60y. What is the time?
Then would you do 20?
Yeah, the time that you're taking is 20 minutes per haircut. So it's x times, we'll make it 20, plus y times 70. So that's the total time you're going to take.
Okay.
and the total time has to be less than 24 hours. So this function, less than 24, now I got everything in minutes, so let's make this in minutes also. That's one thing you have to be a little careful with here. You can work a total of 24 hours, which is 1,440 minutes.
Yeah.
Okay, so there is one equation. Time has to be less than 1,440 minutes. The income is 17x plus 60y, and you want to maximize that. All right. See if I can remember how to do a linear programming problem here. We want to graph it.
Oh.
Go ahead.
Oh, that's just weird. I didn't expect that I had to graph it.
Well, maybe we can solve it without graphing it here. The question is maximizing the income, right?
Yeah. Oh, is this one where you have to find the points and find which point?
Yeah, in other words, what you end up with here is a function perhaps that looks like this.
Right, and you found all the points.
Right, and then this is your income, and so you can examine each point to figure out which one produces the maximum income.
Okay.
Now, how do we get this picture here? Well,
we only have two lines, right? There's two lines intersecting each other. Oh wait, but how do we find the one line if 17x plus 60y isn't equal to anything?
Yeah. Hold on, let me think for a second. Let's see. We know that 20x plus 70y is less than 1440, so I can graph that. X has to be greater than 0, y has to be greater than 0, and this graphs as a straight line. So, I'm not going to have this kind of shape. I'm going to have strictly best way to graph that is to use the X and Y-intercepts. Okay, rather than solving that for y and putting it into mx plus b format and then graphing it that way, if you have x and y on one side and a number on the other, well, the y-intercept comes when x is 0. So the y-intercept is 1440 divided by 70, which,
20.5.
yeah, I don't know why they do that to you, but what is that? 20.5.
About.
Okay. The x-intercept comes when y is equal to 0. So this number divided by 2 is 72. Correct?
Yep.
Not 720, it's 72. Okay. So this inequality is defined by less than or equal to solid line. Which side of that do I have to be on, that line?
The underside.
Okay. And there's two other equations that are implied. Y has to be greater than 0, and x has to be greater than 0. So that makes that triangle.
What happened to the income?
Well, we're going to figure out what income is based on these 3 points. And we know that the maximum income has to come at one of those vertexes.
Right.
Okay, it's almost never this one, because obviously if you make 0 hats or 0 haircuts and 0 permanents, you don't make any money at all. So we need to check that point and that point in the income formula. In other words, the income...
Oh, yeah, we put the numbers into the income formula.
Exactly.
Okay.
And whichever one produces the biggest one, that's our answer. So we'll try this one here. Well, x is 0 there, y is 20.5. So what is 20.5 times 60?
1230.
So that's what you make if you do nothing but permanence.
Right.
What if you do nothing but haircuts?
1224.
Your best solution is to do nothing but permanence. Well, now let's hold on a moment here. 1224. So if you work exactly 24 hours doing permanence, you make 1224, I guess. Yeah, you'd have 1,440 minutes divided by 70 minutes. Or, yeah. So this tells you that, oh, I'm sorry, this was, yeah, that was the best solution. And that was where you did nothing but permanence.
Yeah.
Now hold on one moment here. There's one extra little tweak here that we might want to consider.
Okay.
You have 1,440 minutes to give haircuts. If you do nothing but permanence, how many permanents can you give?
Let me check.
Well, you can give...
20.5.
Yeah, but you can't give half of a permanent.
Oh.
So you can only give 20 permanents.
Yeah. Oh. Ooh. So 20 times 60. That'd only be 1,200.
Right.
As a.
However, that gives you an extra 30 minutes to do a haircut. But that only...
Oh man, here we go.
But that would only give you one haircut. In other words, you do 20 permanents and one haircut. And that would only give you 17.
That's
Whereas
the best. So
by doing all haircuts, and you can do 72 full haircuts.
Yeah.
What's 72 times 17?
That was the 1224, right? Yes, it was.
Okay, so one method you do 1217, the other method you do 1224. This is kind of a weird linear programming problem. It's not typical, but typically I get linear programming from Algebra 2 students. That's the only time I see it. I rarely see it in pre-calc. And so maybe this is supposed to be a little more difficult. Because of the discrete nature. In other words, the fact that you cannot give half of a permanent means you can't give 20 and a half permanents. You can't spend your entire 24 hours giving permanents. You could give 20 permanents, and that would leave you a half an hour to give a haircut, but you can only give one haircut with that half an hour. You couldn't give 1.5.
Yeah.
So you kind of have to consider that aspect of it. And it looks to me like the best you can do is
1224.
1224.
All right. And with the review problems, it doesn't have to be perfect. I just have to get the gist.
Okay. That's a very typical linear programming problem. In most cases, you don't have a triangle. You end up with some sort of a trapezoid. In which case you have to check that point, and that point. And you would end up with a trapezoid by having other constraints. In other words, this might be the time constraint, but this might be, I don't know, you're restricted by law, you can't do more than 20 haircuts. So Y would have to be less than 20. So there would be a horizontal line there, and that would make up the rest of your trapezoid.
Okay.
Okay. And in fact, that is a constraint. I didn't draw the picture properly. When I drew the picture, I drew it as a triangle like that. But there is one more constraint, and that is that Y has to be less than 20. Well, this is 20.5. You can't do more than 20 permanents. So that makes Y less than 20, so our real curve is there, there, and there. And this point here we need to examine. But we did. We did. We said that when we did exactly 20 permanents,
that was the one haircut.
Yeah, that makes $1,200 from permanents, gives you an extra 20 minutes to do a haircut. You can make $1,217. So this one equals $1,217. This one, you can't do this one here, so that's not even part of the equation. You could do exactly 20. That's going to be less, or you could do 72 haircuts, which gives you 1224. So this gives you 1224. That's the best. Yeah, I forgot that you can add that horizontal line there to the picture because you can only, the permanents have to be less than 20.
Yeah. Okay. Well, that was the extent of my questions on this test prep.
Okay.
So,
well, I hope that was helpful to you.
It was very helpful.
Okay.
I needed it.
All right, Brent. Well, let me know if I can help again. Your mom called me today to find out whether there's a spot open. There's actually an easier way for you to do that. If you go to my website and click on Schedule an Appointment, it will show you my complete availability, and she actually could have scheduled automatically, as long as you get, as long as you have an hour of notice. But she called me at like 4 o'clock and wanted a 7 o'clock appointment, so that spot would have been available if you'd have gone online. And the best website to use anymore for me is this one, Digital Math Tutor. For one thing, it can't be misspelled.
Oh, yeah. Okay.
And for another, it's a little easier to use PayPal on digitalmathtutor.com.
Yeah.
But you can automatically schedule on either this one or algebra-to-calculus-tutor.com. Either one of them work pretty much the same. But Digital Math Tutor is a little better website, I think, to enter.
All right.
Okay?
Yeah.
All right, Brent, good luck on your test, and I'll talk to you next time.
All right. Thank you.
Bye-bye.